We have a number of different classes of carbons in these molecules, and we classify the carbons because they behave differently. And you'll see a little bit later on when we talk about various reactions that the different classes of carbons do behave differently. So we have four classes of carbons that we can talk about in these molecules. We have primary carbons, and what I mean by that is that these are carbons that are attached only to one other carbon. So if we look at these structures and identify the primary carbons, I've circled them here for you in red, you can see that they have to be either at the end of a chain or they have to be a substituent hanging off of a chain. These are all methyl groups you've seen before. We call those primary carbons, and sometimes you see that represented as a 1 with a little degree symbol next to it. Again, attached only to one other carbon. On the other hand, secondary carbons are carbon atoms that are attached to two other carbons. So I've identified here all of our secondary carbon atoms in the molecules that we're showing. And I should point out to you that the structures above and below, they're the same structures. We're just showing a couple of different representations. On the top we have skeletal, and on the bottom we have sort of a dash structure, sort of a combination of dash and condensed. Right. So there's our secondary carbons, and we often see those designated as a 2 with a little degree symbol next to the 2. Tertiary carbons, as you might have already guessed, are carbon atoms that are attached to 3 other carbons. In these structures, I only have the 1 tertiary carbon atom showing. And again, this is often shown as a 3 with a little degree symbol next to it. And finally, we have what we call quaternary carbons. And those are carbons that have 4 carbons attached. Okay, so they're attached to 4 other carbon atoms. And there we have our quaternary carbon. The odd thing is, though, is that you never see a quaternary carbon represented as a 4 with a degree symbol next to it. I've never seen that, and I can't really tell you why we don't do that. We just don't. All of these molecules that I'm showing you here have 5 carbons. They all have the same formula, C5H12. They are constitutional isomers of each other, so they have to have a different name. Our straight 5-carbon chain we call N-pentane for normal pentane. The isomer that you're seeing here in the middle is isopentane. And the constitutional isomer that has the quaternary carbon with 4 carbons attached to it we call neopentane. You've seen how we name unbranched or normal hydrocarbons. We figure out how many carbon atoms there are in the chain, and we describe that according to the number, and then we add A and E at the end. You've seen the nomenclature for some small branched hydrocarbons, isobutane, isopentane, and neopentane. And these are actually what we call common names. Very complex molecules can also have common names. For instance, this molecule that I'm showing you here is called myrcene. Now, you can't tell much from the name about the structure of this molecule. About all that you could figure out is from the ENE, or the ene at the end, that this molecule should have at least 1 double bond. If you saw that name, that's about all that you could know about it. It doesn't really tell you anything. Now, there are literally millions of compounds that are known, organic compounds that are known, and nobody can memorize millions of common names. So we have a system of nomenclature that is what we call a systematic method for nomenclature, and that's what we're going to describe. So a molecule like this probably doesn't even have a common name, and you would want to name this molecule so that you could figure out the structure if I gave you the name, or if I gave you the structure, you should be able to figure out the name. So we use the system of nomenclature that is systematic, and it was developed by what we call UPAC, or IUPAC, which is the International Union of Pure and Applied Chemistry. And they've come up with a set of rules for naming organic compounds. So we're going to look at the rules for naming alkanes that are a little bit more complicated than just the normal alkanes or the straight or unbranched chains. So here are the rules. First, you're going to look at the molecule and select the longest continuous chain of carbon atoms, and that's going to be your parent compound, and you're going to name that according to the number of carbons in the longest continuous chain. So for instance, if I have this molecule here, my longest continuous chain is 5 carbons long. So this molecule is going to be a pentane, right? Some sort of a pentane. But what about that group right there? And I've already told you that that group is a methyl group, all right? We've seen that in some earlier videos. Well, when you have a substituent or a pendant group hanging off of a parent chain, you have to name it, and these are the names that we use. So for 1 carbon, or CH3, we call that methyl. 2 carbons, we call ethyl. If we have 3 carbons, we would call that propyl. 4 carbons, we would call butyl, and so on. So you use those same prefixes that you use to name the normal alkanes, and the branched substituents also have some special names. So we're going to talk right now about the unbranched substituents, and we'll talk a little bit later in another video about those branched substituents that you're seeing here. This is the isopropyl, isobutyl, sec-butyl, and tert-butyl. I'm going to save those for a later video. So we've already decided that this molecule should be called methyl pentane. So I've named the branch that I have on my 5 carbon chain. So my branch is a methyl group, so I would call this molecule methyl pentane. But what about this molecule here that I've drawn below? I have my branch in a different place. Isn't this also a methyl pentane? Well, yes it is. So what I'm going to have to do is somehow indicate to you where that methyl group is on the 5 carbon parent chain. So let's go back to our rules. We've already selected the longest continuous chain of carbon atoms, named that as the parent. Now you're going to number the carbon atoms in the parent chain, and you're going to start from the end closest to the first substituent, the first carbon that has another group attached to it. You're going to name the group that's attached to it and designate the position on that parent chain by using a number, or what we call a locant. If I number my 5 carbon chain, I have to start closest to the end with the substituent, or with the methyl group attached. So I'm going to start from the right. That puts my methyl group on carbon 2. So this molecule is 2-methylpentane. For the second molecule that I've shown you, which is also methylpentane, it doesn't really matter which end I start numbering from. If I number from the left or I number from the right, that methyl group is going to be attached to carbon 3, either direction. So this molecule would be called 3-methylpentane. You may come across a situation where you have more than one of the same substituent. So you might have 2 methyl groups or 3 methyl groups. So what you're going to do in those situations is use the prefix di for 2, tri for 3, tetra for 4, and so on. You might also come across a situation where you have different types of alkyl groups. You might have a methyl group and an ethyl group. And in those situations, you're going to list those groups in alphabetical order. Let's look at a few examples in the next video.